It's up to you.
So, good afternoon, everyone. So I'm Anjali Jha, and I'm presenting this paper, Fate Protocol, which is Perpetual prediction tools. I've worked on this with on collaboration with Dr. Bruno and Raj Shah. So, what is Fate Protocol? So, how is it different from traditional order books or like pools? So, like in order books, what happens is like people bid and there are asked for the same, and there are fixed expiration dates and okay. So sorry about this. So prediction pools instead of what is the novel approach over here? So we are using prediction pools instead of order books. So what are the key features of it? That it is perpetual. There are no expiration dates. Then there are continuous liquidity via pools because every transaction that happens, like when people buy or sell, it directly goes into the pool, that is the reserve. So whenever anyone want to redeem the token, they can directly do that. There is no like bid and ask. So there is no insufficient liquidity. And it is oracle driven. Basically, there is an underlying asset that is being tracked. So on movement of that asset, the price of the token gets changed. And it is path independent that we will be discussing in the next slides. So core innovation is that we are combining prediction markets with liquidity pools. This creates an environment where no one has to wait like for bidding and asking. And what problems are we solving? It is insufficient liquidity, fixed expiration dates, order book limitations, and timing manipulation. Timing manipulation is getting addressed by the use of path independence. So there are like five main components that are reserves of bull coin, reserves of bear coin, then supply of bull coin and supply of bear coin. And lastly, it is the P is the variable that is being tracked by the underlying asset, that is oracle. So phi is the fee that is being used. In this case, we are using 1%. So token prices get updated like in the case of bull, it is reserve of bull divided by the supply of bull and vice versa for bear. And the total reserve always stays the same. It is like bull reserve plus bear reserve. So there are three main operations that happens. That is purchasing of tokens. That is the buyer like purchases bull or bear tokens. So deposit like he has to deposit a base asset and he receives the respective bull or bear token against that. And fees goes to the respective reserve. And for minting, the formula being used is the whole minus the phi, that is whatever percentage of fees is being deducted multiplied by the amount that is deposited by the user divided by the price at that moment. And next operation is token redemption. That is like whenever anyone wants to sell the token, so they burn their position and they can withdraw the base asset that was against which they had purchased the token. So fee, in this case, the fee is sent to the opposite pool. So that leads to our next property, that is zero sum. We will be explaining this in the next slide. So lastly, the last operation is variable updation. Every transaction that is like every operation that is happening, they happen in two stages. That is, once it gets updated, the underlying reserves get updated, and next is normalization, so that it is bound to whatever original value is there. So effect is that total reserves are preserved, reserve redistribution, and variable P gets updated. So variable updation mechanism consists of two steps, that is update and then normalize. In update step, we are using an intermediate value where we are changing the reserve which is proportional to the price change. And then we are normalizing it so that the reserves doesn't go out of the bound. So by doing this, our reserve gets preserved, like stays preserved. So this is the first theorem that is explained in the paper, that is reserve preservation. If a variable gets updated, like its price changes, it decreases or increases, which is being fetched from the oracle. So by doing that, whatever happens, in this case we are not considering the fees, so our reserve stays preserved. So asset neither gets created nor destroyed, and conservation of value is guaranteed. Protocol maintains solvency, that is, you can compute the buying or selling value. Then this is the upward prediction adequacy. What happens here is, in any point, like any given point of time, if the value increases, that is underlying price changes and the value increases. So you like, yeah, when price increases, so we have to, so the next price should be greater than the previous price that was there. So in that case, if price increases, the bull coin will win, and by increasing that, the bull coin holders benefit, and bear coin reserve decreases, so correct predictions are rewarded. So this is the zero sum fee structure, that is purchase fees, like zero in this case. Whenever the token is purchased, the fees goes to the respective reserve, and in case of redemption, the fees goes to the opposite reserve. By doing that, no value leaves the protocol, and it is a self-sustaining liquidity. Long-term holders benefit by this, since the value gets accumulated in the reserves that are backing our tokens basically. So this is the, like, if there, this is an example, if there is a price change of 50%, returns is 29.6%, and in case of negative also, bear holders get benefit of that. So this is theorem 3, that is the inverse of second theorem that we saw. So in this case, if the bear coin holders benefit, so because bear coin reserves increase and bull coin reserves decreases, symmetric to upward case. And this is path independence. In this case, our value, that is final outcome, is dependent on initial variables, initial position at whatever it was. So for any path from P0 to PT in any point at the given time. So it depends on these three intermediates. Yeah. So no timing advantage, no manipulation possible, deterministic, like outcomes are deterministic, and it is mathematically elegant property. This is an example walkthrough. So here we are keeping the fees of 1%. So Alice deposits 50 ETH, and for that he gets 49. For that she gets 49.5. So reserves becomes 51 and the supply becomes 50.5. And by doing that, we are calculating the value. The average becomes 1.105, and like bear coin value becomes 0.914. So this is the comparison, like all the existing solutions. So like our aspects are market type. So in LMSR, event-based prediction market, and CFMM, like decentralized token exchange. And how is Fate protocol different? Because it consists of perpetual prediction pools. So liquidity models subsidized by a market maker. Yeah. So these are the differences, and these are the aspects: expiration, pricing mechanism, reserve dynamics, key advantages. So these are the application and use cases. So it can be used for prediction markets, that is asset prices, weather data, any kind of oracle can be used that don't expire. Then like it is risk hedging, buy, bear to hedge, capital efficient, alternative to stable coins. And deep like alert, track, bridge tokens, early warning system, sentimental legals, monitoring, real-time ratios. So oracle consideration, multi-oracle integration. So these are the implementation. So this is the home page, explore page. That is the create page. This is portfolio page. And this is the page where you interact with all the tokens, that is bear coin, bull coin. And this is the underlying asset that we are tracking, and there is another asset that is backing this. So these are the future direction. And research, like there are alternative update mechanism, like one we discussed, logarithmic based. Then game theoretic analysis, like how various rational agents will behave in this situation. Then security model, since we are using oracles, so what if the price doesn't get updated? So we are working on that as well. And formal verification. So integration, it can be used for DeFi composability or Fate as oracle service, since it can show in which direction the market is leaning. Then additional applications and cross-protocol interactions. So vision, new composable DeFi primitive for risk management. So what are our key takeaways? That Fate protocol offers perpetuality, always liquid, path independence, zero sum fees, general purpose, and it is oracle driven. It is proven by four theorems, that is reserve preservation, upward prediction adequacy, and downward prediction adequacy, and path independence. So our core innovation was a new DeFi primitive that fuses prediction markets and liquidity pools into a perpetual mathematically sound system. So thank you. Any questions?
So implementation is done for SUI, right?
It is done for two versions, that is EVM and SUI.
Okay, and Solidity is for Ethereum?
Yeah.
So how efficient is that in practice? So how costly in terms of gas usage?
Currently we have deployed it, and we are making sure that oracles are whatever oracles are being deployed. So we have deployed it on one is the test net, and second one is okay. Okay, can you repeat the question? So sorry.
So how costly is Ethereum implementation in regards with Ethereum gas usage?
Okay.
Because well, it's well, from design quite promising contract, but yeah, is implementation heavy for Ethereum network or not really? That's the question.
Yeah, so on Ethereum, the fees might be high, right? So I would
Yeah.
imagine that if people deploy these prediction pools on Ethereum, they could still do it, but it wouldn't make sense to buy small amounts of bull coins and small amount of bear coins, right? Because the fees would be too high. So prediction pools on Ethereum would probably involve large amounts.
But then
But this EVM implementation that Anjali showed is multi-chain. So it can be deployed on any EVM compatible chain. And I think we have deployed it.
On Ethereum Classic and Gorilla testnet.
Okay, so on a testnet and on Ethereum Classic. So on Ethereum Classic, the fees are quite low. Yeah.
yeah, because for order book DEXs, for example, they are not popular on Ethereum, and AMM LPs got popular mostly because of gas usage, actually. So order book DEXs were not efficient.
Yeah, exactly. Yeah, that's one motivation for Fate. Yeah, to have this kind of pool mechanism for prediction markets instead of order books. Yeah.
Makes sense. Yeah.
But yeah, even on Ethereum, even with a pool approach on Ethereum, it's still too expensive for small amounts, right? So even
So for small amounts, then you consider for secondary markets to solve the issue, like AMM LPs.
Well, if you want to have some pools where people would buy bull coins and bear coins in small amounts on an EVM chain, it would have to be an EVM chain with low fees, right? Like Ethereum Classic, Polygon.
Yeah, but AMM pools, MMLPs, well, not that costly also, because it's simple formula, right? And
Yeah.
that's it. Yeah, that's why they are so popular, because users are not paying much in comparison with order book decks and so on.
Yeah.
Any questions?